Alright, welcome back guys. So we start on lesson 6.1, discussing rational expressions and functions, and then we also going to look at how to multiply and divide rational expressions. So just quickly, the definition of rational expressions is when you have a fraction of two polynomials dividing, and the polynomial in the denominator is non-zero. So an example would be something like this here, or some more example would be x squared plus 1 over x squared minus 1, or x squared plus 3x plus 2 over x plus 1, or any two polynomials dividing. So that give us a rational expression. So another word for rational is fraction. Rational is just a more formal term that we're using. So let's look at the first example here. What do we mean by finding these values? So given this function h of t, t squared plus 5t over 2t plus 1, this is a function that consists of rational expression within. So this is a rational function. So this is an example of a rational expressions. Rational function, not expressions. All right. And we asked to find what the value of function is when when t is 1. So all we do is plug in the 1 for t. So 1 squared plus 5 times 1 over 2 times 1 plus 5. And that gave us 6 over 7. So this is saying that when x is 1, y is 6, 7, right? So that means x is part of the domain there. So if we're going to find the set of all domain for this function, we're looking for all the x, all the possible inputs that we can use for x, such that we guarantee the output. So in this case here, we can work backwards. We can say, okay, well, what is one value of t? Sorry, this is not x. What is one value of t that we cannot use as an input because it doesn't give us an output? So consider when t is, let's say, well, let's see here. If we happen to pick a t that makes the denominator equal 0, then if we do that, we get negative 5 half. So if t equals 5 half, we're going to get this thing equals 0, and we can't have a fraction divided by 0. So therefore, this here is being excluded from the domain. So the way we write the domain is that it's all the real numbers t such that t cannot equal to negative 5 half. So that's the domain. If we want to write this using interval notation, it's going to be from negative infinity to negative 5 half, parenthesis, union negative 5 half to positive infinity. So this is the interval notation to saying that, hey, we exclude just the single value negative 5 half. Everything else should be part of the domain, because everything else we plug into this rational functions will guarantee an output. Okay, that's how we find domain for rational functions. Next, let's look at how we're going to simplify a rational expression. So let's look at some example here. Let's see. Let's look at this example. It said write the function in simplified form and find the domain. Okay, so example. All right. So first of all, is there any way we can simplify these functions first? Well, the answer is yes. So we use factoring from the previous lesson. We can say, all right, let's do this in x. Let's not use in t. We can say that in the previous chapter, we learned how to factor differences squared, right? So that becomes x plus 3, x minus 3, and then 5 comes out, so x plus 3. So we're saying that the x plus 3 cancel out. So this rational function here is equivalent to x minus 3 over 5, as long as x not equal to negative 3, right? If x is not equal to negative 3, these two expression or functions are the same, because we just took out factor of x plus 3. Because when x is equal to negative 3, we get this here being 0, and this function here, you can't have x equal to negative 3, make the denominator equal 0. Next, so for this one, I can have that. We factor out 7 there. So now we're looking at 2 minus x and x minus 2. Those factors are almost the same, but they're different by a negative sign. So we can cancel out the x minus 2. And then there's a negative 1 left behind. So we have negative 1 over 7. So if you look at 2 minus x, right? And then if you look at negative 1 times x minus 2, that gives us negative x plus 2, that gives us 2 minus x, right? So when we cancel this out, they're different by negative 1, so that gives us negative 1, 7. So the restriction in this case is that x cannot equal to 2, because if x is equal to 2, the denominator equals 0, so that's the restriction. Let's do some more example, how we simplify. Let's do this one here. Let's do that one. Let's do a couple of these. All right, so we want to simplify these rational expressions. So we'll just mainly use factoring to cancel out the common factor in the numerator and denominator. For a, I can factor the top to be x plus 5 and x plus 1. Denominator, that is the difference of square. So x minus 5, so that cancels out. So this simplifies to x plus 1 over x minus 5. Okay. Let's do d next. D on the numerator, I can do, well, that's a difference of squares. So I can do 3x plus 7 and 3x minus 7. Denominator, I can take out a 4. So that gives us 7 minus 3x. Okay. So 3x minus 7 and 7 minus 3x. So that's kind of like opposite factor there. So we can cancel that and say, okay, well, there's a negative 1 left behind. So that gives us negative 1 times 3x plus 7 over 4. So that becomes just negative 3x minus 7 over 4. So that is the answer. Let's do some multiplication and division of rational expressions. Let's do these right here. Okay. Right. Okay, so to multiply fractions or rational expressions is very similar to when we first learned how to multiply fraction. So we just multiply across numerator to numerator, but in this case here it's hard to do that because these are polynomials, so we don't want to just multiply across. We want to simplify first, reduce each rational expression first before we multiply. That's where the factoring comes in. So what we want here, what we want to do here is we want to factor each rational expressions and then reduce it first before we multiply. That's going to be a lot easier. 3 and then x plus 2 times n plus 2. We can take out a 2, so that's 3 minus n, right? So we can say, all right, I can cancel out n minus n plus 3, and then n plus 2, and then this one is an opposite factor, so there's a negative 1 there. So we end up just with negative 1 over 2 is the answer. Okay. Now let's do a division one. Division is same thing with division with fraction, is taking the first fraction, multiply the second fraction with reciprocal. So let's do B here. So first we apply the definition of fraction. We can say to divide fraction or rational expressions, it's the same thing as multiply by the second fraction reciprocal. right? So that's the reciprocal. And then let's factor. So that's phi x minus 2, phi x plus 2, x minus 3, x plus 3 times x plus 3 over 2 minus phi x. We can cancel x plus 3, and then the phi x, and then phi x minus 2 and 2x minus 5, that's the opposite factor, right? So there's a negative 1 left behind, so negative 1 times phi x plus 2 over x minus 3. Distribute the negative 1, so that gives us negative phi x minus 2 over x minus 3. Okay. Alright, well, in the next video, I'm going to show you guys how to add and subtract rational expressions.